Okay. Why would I want to do things in either of these ways? Well, depth-first search, mostly, to be honest, you do depth-first search when you really don't care what order it's in. And depth-first search is just easier because you're going with the flow of how the language represents things and using higher-order functions like map to help solve your problem. So it's just easier. But also, you want to do it depth first because you want to group things that are related. So if we're printing out this tree, it's actually much more sensible to say Beatles, John, Paul, George, Ringo, Who, Pete, John, Keith, Roger, Kinks, Ray, Dave, etc. Okay, so put the group name and then the people in the group, rather than the 3 group names and then all the people in a row. It's more informative to print it out depth first. Okay? Why would we ever want to use breadth first? The answer, broadly speaking, is about searching of some space of possibilities. And the canonical example is I'm writing a program to play chess. So I hope you all know that 30 years ago, chess was the canonical example of something that a computer will never be any good at. And today, the world's champion chess player is a computer. Not so much because we got smarter, but because computers got faster and more powerful. So how do those computer chess programs work? Well, the way they would work ideally is they would construct a complete tree of possible board positions. Right, so the beginning board position would be all the white pieces in these 2 rows and all the black pieces in those 2 rows. And then you'd take every possible move for white, and that would make a child node. And then each possible move for black, based on that move for white, would be the children of that, and so on. And you'd go all the way down until you reached leaves. And a leaf node would be somebody wins the game. Or you get in a cycle and it ties. And then you would work your way back up the tree, trying to figure out how we can force a series of moves that leads to me winning. Sadly, the number of possible board positions in chess is, I think this is true, greater than the number of atoms in the universe. So we aren't ever going to construct that tree in its entirety. And instead what happens is you build that tree breadth first to get as deep as you can before you run out of time. Because you only get a certain number of minutes per move in chess. That's why they have those clocks like in the movies, bam, bam. So you take almost all your time and you spend it building this tree breadth first, because you don't want to chase down a dead end and not get to some other possibility. So you have to look at all the possibilities at once. And then when you're almost out of time, you stop building the tree down and you start evaluating board positions. Right? Now, the board positions that you're looking at, nobody's won or lost the game yet. You're like 8 moves ahead of yourself or something. And so what you have to do is evaluate those board positions basically the way human chess players do. Right? You say, what's my pawn strength? And how many points of captured pieces do I have? And all of those questions that chess players ask. It's in the books. And so you come up with some figure of merit for each board position, and then you work your way up trying to force the best possible board position that you can force your opponent to give you. So making that tree is an example of why you would want to do something breadth first. Because if you do it depth first, you're going to run out of time before you have an answer. Okay? Another reason is it's not that you would run out of time, but you're looking for the minimal possible path to a leaf. Okay, so my favorite example of that is everybody take the kind of IQ test where they say, You have a 3-quart pitcher and a 5-quart pitcher, and you're down by the river, and you're trying to measure 4 quarts, and the pitchers aren't marked. How do you do it? And you can pour from one to another. All that. Those are pitcher pouring problems, and their trees are, quite simple, basically. So you could traverse the entire tree in no time if you're a computer. But the answer you want to come up with is the one with the fewest possible pourings from one thing to another. And the way to get the fewest possible steps to a leaf node is to do it breadth first. So can I find a leaf node one level down from my starting point? If so, finished. If not, construct my grandchildren. Can I find a leaf node in there? No. Construct my great-grandchildren, and so on. So that's another reason for doing breadth first search.